And we should be live. Hello, everyone. We're gonna wait a couple minutes before we get going into the actual discussion. But as people are joining in, if you want to say hello in the chat, maybe where you're streaming from, that's always fun to hear about. I'm streaming from Seattle. John, where are you coming in today?
I'm in New York right now. I am in a not officially a WeWork, but a WeWork-esque place. So I've commandeered a room out here.
Nice.
Yep.
I'm actually leaving for New York tomorrow morning. So
oh, nice.
How long are you there for?
I am actually permanently here now. I moved to New York from the West, from San Francisco, maybe 2 months ago. So I will be out here for, well, I say that, and I'm going to be out here for the next 2 weeks before going back to the West Coast for some events and things that we're doing out there. So kind of bouncing around.
Yeah, awesome. Yeah, I know Arize has a big San Francisco presence, I believe, right?
Yeah, totally. We're originally out of Berkeley, so we kind of have these ties to Berkeley, and then that becomes ties to SF.
Awesome. Yeah. Very cool. How do you like in New York so far?
It's good. It's cold, man. I think I knew this going in, but it's definitely chilly out here. But it's been fun. I was in San Francisco for almost a decade before this, so it's nice to have just a new update for sure.
So I should bring at least 2 layers.
Yeah, well, now it's actually, as I say that, now it's getting nicer. It's like 50 degrees out now, but it had been sort of sub 30 for a while.
Perfect timing for me.
yeah, putting on a good show for you as you come in.
Awesome. And again, as people are joining in, we'll get going here probably in like another minute. Just want to allow for people to roll in. So if you do want to say hello in the chat, I know it makes it more fun for me, probably more fun for everyone else too. And again, if you just want to put maybe where you're streaming from, and if you want to add more details around what you're building, I mean, today's talk we'll go into a little bit more, but it's about LLM observability. So I assume a lot of people here are building with the LLMs or thinking about building with LLMs. So if you want to share in the comment, whether you're watching on YouTube or LinkedIn, what you're building, even just at a high level, that's also super interesting and allows us maybe to tie in responses to like something more specific that you're encountering or building, which would be great.
Yeah, very curious to see what people are working on. I feel like it changes every few weeks here what the common app that people are building is. So.
And a new state of the art model every 3 days, I feel like.
yeah, very true. We're like scrambling to support 3.7 and then 4.5 and all these new updates as well. So.
Awesome. All right, well, let's go ahead and get started with the introductions, and then that'll be like another minute before we get into the discussion as people are still joining in. So just as kind of a quick intro, again, welcome everyone. Feel free to say hello in the chat, post where you're watching from, what you're working on. That's pretty interesting. My name is Sage Elliott. I'll be the host for today's Union Fireside Chat. At Union, we build widely used tools around AI orchestration and making compound AI systems generally more robust or efficient and reliable. You might know us from our open source called Flyte, Flyte, which I'll share a link in the comment, or links are in the description, I think, already. And what was I going to say about that? Oh, Flyte, which often people search it the other way, but it's used by thousands of company production. And then we've also are just launching model and app serving, which is really excited to tie into today's conversation with Union AI. So if you want to sign up for a serverless, you can check that out. We'll be doing a lot of workshops and more content on it, so stay tuned. But today's chat isn't about Union. It's about kind of, well, either about building your LLMs or about when you're putting those LLMs in production, like with the model and app serving. And we're going to be talking about how to make LLM models and applications better with LLM observability. And we have John with us from Arize. Welcome, John. And just to reiterate today's topic for people rolling in, we're going to be talking about LLM observability, tracing, evaluations, and some insights that you get with a platform like, well, John is going to mention Phoenix from Arize, but when you get it from an LLM observability platform like this. And also, before John even goes with this intro, I'm just going to also post a link to, you had a new course come out on deeplearning.ai that looks awesome, which is evaluating AI agents. I think something like that is on so many people's minds. And then also I'll post a link to their open source Arize Phoenix, which you'll learn a little bit more about in this talk. But welcome, John. Before we start getting into the discussion topics, do you want to introduce yourself? Maybe let us know a little bit about your background, and we'll go deeper into Arize and LLM observability, but maybe at a high level, kind of what you're working on there.
Definitely, yeah. Sage, thank you for sharing all of the links as well too. I feel like that gives everybody on the same page, so I appreciate that. But yeah, nice to meet everybody here. I'm John. I'm our head of DevRel at Arize. So we're focusing on all of our kind of go-to-market from the bottoms-up side of things for DevRel. We're doing a lot of our developer advocacy, doing a lot of our events, content, all that kind of stuff on our team right now. My background is kind of on the engineering side, and then I did some sales and solutions engineering roles at a previous startup called Branch, which I doubt many folks here will be familiar with, but you've ever clicked on a link, say a Spotify link that one of your friends texts you and it opens up into the Spotify app, that was powered by us. So there was some nice back-end infrastructure that was going on there. So worked in that for a few years, went back to school, got a master's, and then joined Arize back in June last year to kind of help build up this whole open source go-to-market that we have. So been mainly working with Phoenix, which you guys will hear more about. It's our open source platform, but handling a lot of how we bring that to people, how we kind of create a community around that tool, and how we do a lot of kind of education to the subject of the course that Sage posted as well. So excited to talk through all this with everybody.
And feel free, as I saw a whole bunch of people join, so feel free to ask questions in the chat if they work for timing. Hopefully we can get to them, but again, we might use that data to kind of inform some answers that we'll be talking about as well. One other thing, John, that I like to tack on sometimes, especially when someone's in DevRel, is how did you get into DevRel?
Yeah, kind of by happenstance, as I'm sure is the answer for a lot of folks. I had this sort of half engineering, half external facing roles previously, sales engineering, solutions engineering, some of those kinds of things. And then I knew I wanted to get into AI. I knew I really liked having the technical side, and I liked kind of the teaching aspect and education aspect and getting to chat with people and have the social side. So I found my way to Arize through an old coworker, and then kind of started learning the dev advocacy trade somewhat recently still. But kind of feels like something I've been doing a lot of already, just now a name put to it, which I'm sure is a common sentiment among all the dev advocates.
I feel like that's often the story. Is like, well, I was already doing it, but I didn't know I was doing it as a role. And for people who don't know, like DevRel is a really fun role. If you like building stuff and talking about it and educating people, it's one I always like tell people to go look at if you haven't thought about it as a career path for you.
100%, yeah.
All right, so let's start with kind of getting into the topic today. And we could just start off the conversation with what is LLM observability, and maybe kind of why is it crucial for all the AI applications going into production today?
Yeah, definitely. So observability, for anyone who doesn't know, it's kind of this broader common practice when it comes to software development of understanding everything that's happening inside of your application, tracking things like logs, as well as evaluations and metrics on how your application is performing. And it's a discipline that's kind of been reinvented slightly with LLMs, because now you suddenly have this much broader kind of output space of what you can get back from these LLM-based applications. So there's this specific area now of LLM observability, and it basically means knowing exactly what happens inside your application for each run of that application, and then being able to capture metrics on that, evaluate performance, and kind of understand how everything is working at a pretty granular level there. So it's something that gives you that visibility basically into your tool. And we see it becoming kind of critical because, again, you have these applications that are built on LLMs, you're going to have a whole range of outputs you could get. There's this much wider kind of opportunity and margin for error in some of the responses that you get back. And so having that observability becomes really, really crucial. And I mean, we see this in practice too. We see companies launching with chatbots or launching with agents that can do things like sell a Chevy Tahoe for $1, which I think some folks might have saw that story from a little while back. So there's almost this like distrust as well too, both on a user side as well as an enterprise side of how these AI applications perform. And so having observability gives you a way to kind of build some of that trust as well. So it's really helpful for understanding what's happening and then for building trust with the people that are going to use and interact with the application.
Yeah, and eventually, like, and you might touch on this a little bit later, but it gives you a lot of insight to what's happening in production. You can take that data and then fine tune a model, and again, you're building trust with that, just like you're saying. But it allows you to basically look at what is actually happening, and then you could like re-edit those bad responses and use that as training data and make your fine tune your LLM to act more accordingly.
100%. Yeah, you will talk. I definitely will kind of dive deeper into this as we go, but building the whole cycle around how you improve your application over time.
Yeah. And so at a high level, how does Arize's open source tool Phoenix, which is, again, I shared the link if you want to go check it out, or it's in the description, or you can Google Phoenix GitHub, it'll probably come up. How does that tool help with teams, and how does it help with monitoring and evaluating and debugging those LLM applications?
Yeah, so Phoenix does kind of four things really for you. So one is captures traces on what's happening inside your application. So it gives you kind of the visibility of the runs of your application, as well as what that looks like in production, lets you track all of that. And then those traces can become the basis of evaluating your application. So it helps you run LLM evals, human evals, different kinds of evaluations on top of your data to understand performance. And then lets you experiment with different kind of inputs, test cases, different kind of analysis there. And then we actually recently launched some updates around this too, but it also gives you the ability to iterate on different prompts that you're using, test different versions of those prompts across data, kind of use it as almost like a prompt hub or an area that you can kind of manage your prompts and play around on them and do some like what if analysis as well. So it's really meant to be kind of like the second screen that you have open. So you're building in Cursor or Windsurf or wherever it might be, VS Code, whatever your IDE is. You can have that on one side and have your kind of Phoenix window on the other, and see all the information that's happening as your application runs, see your test results, see all those different pieces there.
That's awesome. And I love the idea of having better insights to just your prompting
Yeah.
and what's happening there. So many people I know will change prompts, and then sometimes I'll ask, like, how do you know it's actually better? And maybe they
Yeah.
have like a couple prompts, or they prompt, or they look at something themselves, but often it's kind of like, well, I don't know, I think it's better.
Yeah, the vibe check is a very common metric there, I feel like.
Yeah.
Yeah.
So diving a little bit deeper into, like you mentioned, tracing.
Mhm.
First, actually, maybe we could go into what is LLM tracing, and then it's also a key feature of Phoenix. And if you could maybe walk us through a real world example where tracing has helped identify and resolve like an issue. That'd be
Yeah,
awesome.
totally. So tracing, for anyone who's not familiar, is the idea of tracking either like function calls or blocks of code or kind of these individual operations in your application, tracking those, tracking some kind of attributes associated with them, like inputs or outputs or the time taken or things like that, and then logging that into a system like Phoenix or whatever other observability system that you have to be able to visualize that performance. And so you can end up with these kind of hierarchical traces that are made up of all those individual steps. So if you're building, say, an agent, for example, you might have steps for your initial like router call if you're using an LLM for routing to get the response back there. You might have individual kind of traces or spans here for your tool calls, for your, say you're using a vector database for your retriever calls from that vector database, and kind of all of these operations that happen around your LLM calls in addition to those LLM calls. And you can see this whole hierarchical trace of, okay, your agent got one input. How does it make its way all the way down to one particular output? What are all the steps that have to happen there? And so you get this kind of rich view to see all of that information. So super useful just to kind of get a sense of how your application is performing, kind of what's happening with different runs. To give you kind of a concrete example, we had somebody who recently was working through an agent that could, it's kind of a coding agent that could also interact with some databases. And to do that, it would generate SQL code, it would run that SQL code, and then retrieve a response back, kind of manipulate that, pull it into another system. And we were seeing cases where you put in a query where the agent should definitely have a response back, and it comes back and says, hey, I didn't find anything, sorry. And you kind of have to say, okay, what do I do from here? If you don't have an observability solution, then you are logging breakpoints, like you're going step by step. And then I don't know if anyone has run into this, but I've often had situations where I do that and then it works fine. And I'm like, okay, where's the error? I know this breaks sometimes, but it didn't break this time. So it can be annoying to kind of reproduce. If you have an observability solution, and in this case, we use Phoenix to be able to go through and say, okay, I have this whole detailed log of all the steps that happen. And we could go in and see that the actual step that failed was the SQL generation code step, basically. Like it generated SQL that had a slightly different format for a column name than it should have. And so we can know that that's the piece to change. And then actually, I can talk more about this if people are curious, but we could then kind of pull that into the prompts playground that we have and just do like what if analysis. So that kind of hit a button that brings us into a view where we have all of the chat history, all of the tools, all the different structured output requests, all the kind of accoutrement around the LLM call. And we could just right in there, try out different versions of the prompt until we got the one we wanted, take that out, go put it back in our code, run and see if we get anything better there. So that was kind of a real world one we ran into a little earlier this week.
Awesome. Yeah, that sounds like, I mean, yeah, a lot of people have probably gone through debugging without tracing, with all those different steps, and it's kind of a pain. This sounds way better.
I see a couple questions popping through here as well too, and I think we're kind of talking about tracing. So there's the first one here around like integrations and hooks in different platforms. I think it might be geared towards the Union team, but I'll kind of co-opt it here as well too. For tracing as well, and when people kind of think about setting up all those calls into whatever system, the reality is that today a lot of that happens automatically based on these integrations. So Crew AI, there's a question about whether there's integrations with Crew AI and LangGraph and these different tools. And so with each of those tools, we have these automatic instrumenters that will kind of pull data in for you. And that's what the bulk of, like if you're getting off the ground quickly, most solutions are going to have some kind of automatic instrumenters to capture this for you. So setup process is pretty quick, even if you're using us or another tool. It's usually pretty quick to get some of that data in to get a sense of pretty detailed trace view there for sure. Yeah. I see another one. I can tackle the other ones if you want. Sej, I'll leave it up to you.
You can go for it. You can go for it.
Okay, cool. Yeah, there's another question, which is how is Phoenix different from Langsmith? It's a great question there. Both are observability tools, both do evaluation at a high level there, add experiments and some similar features. I think the few biggest differences, one is that we are totally open source. So the whole application of Phoenix is open source. You can run it yourself. You can go download it, run it on your computer. You can just install the Python package, and then there's a command Phoenix serve, which will spin up an instance for you. So most of our users are self-hosting our platform. They're setting it up themselves, and they're actually running it that way. So that's one of the biggest differences. Another piece is that we are built on top of open telemetry, which is a whole other topic, but it's basically like a baseline standard that gets used for observability in a lot of other tools. And so it means that your traces that you capture for Phoenix are going to be the same format as traces you capture for your traditional software observability. Also means you're kind of building on top of 10 years of best practices and kind of set up for that. I think Langsmith has added like functionality to translate some of that recently. So they have some of that, but they're not necessarily built on it in the same way. And then the last piece is we do a lot of our own kind of research into evaluation, into kind of what are the templates that get used for different LLM evaluations, how do different models perform on those types of tasks. We do a pretty big deep dive into that area as well. So we are really trying to kind of focus on also being an authority for evaluation as a process, as in addition to kind of tracing in those pieces there. It's a great question though. Yeah. Keep it going.
Awesome.
There's one more about open telemetry.
Yeah, feel free to keep asking questions, and then hopefully we can get to them either in breaks between, just like John, if you want to answer them, that's totally fine. I'll go to my next question though, which is, so we've talked about tracing and you gave a really good real world example of it. Do you have any kind of common failure points that you see come up repeatedly when people are building their LLM pipeline? And like you mentioned, one example, so I think we get the idea of how an observability tool like Phoenix can probably help mitigate them. But maybe what are some of the common things that people should think about when they're building their LLM pipeline?
Yeah, I mean, I think a lot of it is that you got to remember it's going to be this sort of iterative process. You're not going to sort of build it, get it set up, and have that work. It's even if you got to work on all of your kind of test cases and everything like that, once you put it to production, you will always get questions from users or inputs you didn't expect. And so you have to be able to kind of update that and change that over time. So one of the biggest pitfalls is just kind of thinking it's this set it up and it'll run kind of process. You have to remember that it's going to be iterative there. And so that's kind of one of the biggest pieces that we see. I think the other big pitfalls that we see people running into is either when they are getting going, kind of jumping to this full structured system of how they're going to test everything out. This is kind of the other side of this is like when you are getting going, step one should always just be like, look at the data and look at your application and look at the traces of the first few runs, get a sense of what's happening before you go try to build a whole system around that. And so I've definitely seen people burn a lot of time by kind of, you'd be surprised, but not just like not opening up the whatever the chest and like looking at what's inside to see what the data is doing and how it's performing. So that could be a big one too. I think generally you want to go like simple and start it up simple, and then remember that you're going to be at it for a while. It's going to be an iterative thing. You're going to need to make updates as you go.
And I think that's great advice for almost any type of tool building.
Yeah, that is true. We're reinventing some things, but not everything.
Yeah, same with building ML pipelines and stuff. It's a similar thing. It's like build a simple version of get that pipeline running before you pass in larger models and more complex things. And yeah, it's good to remember that it's an iterative process, and you can start smaller and just expand out into the more complex task that you want.
Yeah, 100%.
Diving down a little bit more into evaluation, and maybe like there's some differences, I guess, from having like an LLM in production and then also the evaluation phase, which at least when I hear that, I think about I'm building it kind of like we've been talking about, and I want to test my prompts and make sure that's all working. Evaluating kind of the output from LLMs is, notoriously a little tricky.
Mm-hmm.
So it's unstructured. You never know what you're getting. What are some of the best practices? Like we've talked about what this kind of looks like in a pipeline. What are some of the best practices for setting up those evaluations as you're building your LLM? And then I'm going to kind of combine another question in there, maybe, is what are the most effective metrics for assessing the LLM performance, and what does that look like in Phoenix? Because I know you have some really cool tools around it, and you hear all these different metrics people using and LLMs as a judge. What does that kind of look like for you right now, or how would you recommend people setting up evaluation experimentation?
Yeah, definitely. So maybe I'll start from the end there and work my way kind of back in the questions. But usually the way that we recommend starting off is kind of going to what I was saying before of like, you want to look at your data, you want to see what's happening, start to look for the failure points there and build your first few evaluations around some of those failure points. And I think that's kind of changed for us over time a little bit. Like I think previously we would say, okay, you're building a RAG system. You're going to evaluate relevance of retrieved chunks. You're going to evaluate the response that's generated by your system for context adherence. You're going to evaluate these known metrics. And those still exist, but I think we're starting to see some tooling is improving. So those same kind of things are not necessarily applicable. And some applications are just sort of changing in the types of approaches that they use to be a little bit broader and a little bit more open in that way. So you do generally want to start by looking at, okay, what are the actual failure points that are specific to me? And then you can start to build evaluations around those. And that can either be your LLM-based evaluations, so LLMs of judge approaches. It can be human evaluations in some cases. It can be code-based evaluations. And typically, the code-based is kind of the best one if you can do that. It's definitely restrictive. So if you're able to kind of create almost like a traditional unit test or something like that for certain parts of your application, that's kind of the best of both worlds, because you can scale that almost indefinitely. You can get deterministic results back from that. So where you can, try to use some of those code-based evaluators, and where you can't, or where you have to have some more of a kind of a flexible evaluator, that's where the LLM evals come in. LLM evals are their whole other topic as well too, of like what metrics do you look at and how do you set that up. So happy to kind of get more into that, because I think that's an interesting area there too. There's a lot of best practices that come from how do you set up your LLM evals. Some of the best pieces that come to mind are like there's sort of your specific best practices, things like you want to use either very large state-of-the-art models to do the labeling, to have it align closely with human representations, or you want to use a model that's been kind of specifically tuned for that evaluation task instead. And then when you're having it output something, you're having it judge the results of your application, you want to have it judge a very specific criteria. You want to have it kind of output labels of classification labels. You don't want to have a continuous thing. So there's all these kind of nitty-gritty best practices and kind of things that you want to do there. But really, when you're approaching the LLM evaluation, the main thing that you should think about with it is that, in a way, it's almost another LLM application that you're setting up an evaluation for. So if you can base it in ground truth, if you can have a ground truth human labeled data set of what you want that evaluator to do, then you can kind of build up a whole system around, okay, let me test that. Let me test different versions of prompts for my evaluator. Let me test these different approaches to get yourself to an evaluator that you can use, an LLM evaluator that has 95, 98% accuracy. And then you can scale that up, and you can now know, okay, this is going to be very accurate in a lot of cases. It's not 100%, but we can kind of get it pretty close. So it's kind of combining the human evaluations with like using those to build your LLM evaluator is a very common approach that we see, especially for folks who are really kind of taking these productionized applications where they need that evaluation piece to be really strong. And so all of that stuff that we help with within Phoenix as well too. So there are different pieces that we tackle there. So I know I covered a lot of ground with some of the LLM evaluation stuff there. But yeah, hopefully that's a helpful run through, but definitely a bigger topic. We have our own webinar just on LLM evaluations themselves.
Yeah, we should do a workshop together on that.
Yeah, yeah, definitely. Definitely.
But I also, like I said, it's like building your evaluator with LLM as a judge, and those techniques is almost like building another LLM application. And it's like I thought of the Watchmen meme of like who's evaluating the evaluator kind of thing.
Yeah.
But like you said, it seems like from kind of what you said, often the practice is you build this evaluator, and then you're using humans a lot to evaluate the evaluator, and then giving feedback to that, and then that gets to scale more because you can use it everywhere.
Exactly. Yeah. Like it's really hard to escape some amount of human labeled data if you want to build a strong application, but you can use LLM evaluators to just multiply the effectiveness of that and kind of use it more broadly. But yeah, you do still base it in some human ground truth as well.
That's really cool.
That's
I like that idea.
Yeah. It's always down to humans as well at the end.
Yeah. Are you seeing a shift? Like you said, it's always down to humans at the end. Are you seeing a shift of, I guess, like humans being used a little less for evaluations as like you get these other evaluators and stuff scaled up?
A bit. I think to be honest with you, by the time we are seeing most people, they've done a little bit of labeling themselves. But I think one thing we are seeing is it's gone from, hey, we have this big giant human labeled data set to we've labeled 50 examples and we're going to take that and that'll be our ground truth. And then we can go scale that into the evaluations that we need. I think that's one thing that we are starting to see is people feel more comfortable with that. The other trend we're seeing is that ensembles of judges or councils of judges where you have like multiple LLMs that are labeling one particular example, and then you take like a majority vote between those LLMs. That is also becoming, this is more on the research side of things, but we're starting to see that crop up as a kind of a preferred approach on the research side. Because again, you can scale it to more, it's still more cost effective than human labeling a lot of times. And we did some of our own kind of testing that we'll have some data out actually soon here, where we actually compared the results of some human labeling services to a council of judges, kind of found the council of judges was almost more accurate in some cases. So we are starting to see that as an approach. We haven't seen as many like enterprises, for example, who are fully pulling the ripcord and saying like, we're just going to do LLMs the whole way down. And so I don't know if we'll see that, but we're starting to see a shift over to that as well. Yeah.
Awesome. This might be a good point too to maybe answer some of the questions in chat that are very related to what we were just talking about too.
Yeah, awesome. Okay, I'm going to cherry pick one of them, but I will try to get to all of these as well because there's one that we just related to what we're talking about, which is, can you explain how you would use ground truth human labeled data sets with Phoenix? And so there's sort of two ways here. One is you can use, like we were talking about, you can use the ground truth data set to kind of build up an LLM evaluator. So you can take a ground truth data set, which is maybe your inputs and expected outputs of an application, plus what the label should be, like that was correct, that was incorrect kind of thing. And you'd use that ground truth set of data to test different evaluation, like LLM evaluation prompts or models or different kind of structures there, and see how closely those models and with those prompts align to your ground truth data. So it's a way to benchmark the accuracy of your LLM evaluator. Phoenix helps you do that because we have an experimentation feature here where you can take a data set, you can run an experiment on it, and then we'll track all the results of your experiment. We'll kind of give you the line by line of that, measure performance over time. So it's a way to kind of move out of your spreadsheet where you're tracking experiment results the whole time and kind of put it into an actual tool here that lets you track that more effectively and kind of run different experiments there. The other way you could use ground truth data is you could actually just run it in an experiment. And this is something that we see a lot of folks doing during the development process is they'll come in with a set of ground truth data and say, this is what I want my application to be able to do, or this is what I want a specific step of my application with this particular prompt and this particular sort of stage of my agent, for example, to do. And then they'll workshop that, they'll use it in Phoenix, they'll use that prompt playground that I mentioned to test out and compare a bunch of different iterations of prompts for models or kind of tool descriptions or whatever it might be there. Test those side by side across your ground truth data set, and then get the results back there. So it's kind of a part of the platform where you can do these more kind of small scale tests where you're taking some data in the development process to build out what your application will look like. So there's a few pieces that you can use those ground truth data sets for there. And then there is another question here on integrating humans into the process. I think we've covered some pieces of that. I guess maybe the last thing that I would want to highlight with that question is that there is this sort of, I mentioned there's an ad hoc combo of unit test thinking and human review and some pieces there. I think that can work pretty well, but I think using that human labeled data set as your sort of test cases that you're going to work towards, and then combining that with, once you've, say you create your prompt, you create your system, you launch it, you trace your application, then you can actually start doing some annotation, some human annotation on the live runs of your application. So you can start to surface, okay, this was a bad run, this was a good run. You can start to label those live examples, and then you feed that back. So then that becomes part of your test cases. That becomes what you test against in development. And so you use kind of learnings from production that you have done some human annotation on as well to feed back into your development process. And so that becomes this flywheel that can improve your application over time. And so that's kind of getting ahead of some stuff that I usually save for the end, but we kind of this cycle that we have of how you can improve your application over time. Cool.
Well, speaking of that, speaking of that cycle,
yeah.
Speaking of the cycle, maybe now's a good point to dive a little deeper. And if there's anything else that we didn't really mention that like Phoenix can help with, it's a good spot to kind of bring them up.
Yeah, I mean, to be honest, we covered a good portion of some of the stuff there. I think it's the tracing, it's the evaluation, experimentation, prompt playground, kind of prompt management are sort of the big pillars of what we're doing right now. Annotations and human annotations and annotation queues is something we've touched on a little bit that's in there as well. So that kind of covers a lot of what Phoenix, the open source platform, does. There is kind of an Arize platform that we have that does some similar things, plus a bunch more. And really one of the big areas there is it has a co-pilot agent that's built into it. And so kind of an interesting thing is we put an agent into the platform that helps you evaluate your agents and other platforms. But that can kind of do things like generating evaluations for you. We can do things like surfacing traces. Say you want to show all the examples where a user got frustrated, you can surface that data for you. So it is cool. And I think it's kind of, I like to think of it as this is the future we're going towards of we're going to have these self-improving or self-healing applications that can improve over time. And we're pretty close to having that kind of loop. It's something that we're probably weeks away from prototyping, I would say, in very much like an R&D research side, something my team's kind of doing some stuff on to see if we can just combine some techniques to do some self-healing, self-improving systems. But I do think that's something that we'll see in the future as well, too.
Yeah, if you have a good evaluation that you feel confident on, it's almost like a loss score you can optimize for with prompts and other type of stuff that you can manipulate for your LLM, which I think is really powerful. So I'm very excited to see what you launch soon, I guess.
yeah, it'll come out as research before we bring it into anything else.
Perfect.
But yeah, it'll be cool, and I hope it works. I think I should probably say that too. I hope it all works good.
Do you have any other favorite features that we didn't mention yet?
I think trying to think if there's anything I'm missing. I think we touched on a lot of them. I think the span replay is one that we kind of mentioned, but it's like that what if analysis I mentioned of being able to take a run of your application, kind of click into what was happening at that particular time in your application, even if it was like some user that was running your app and you were just collecting the traces on, being able to kind of step in at that point and saying, okay, like what would have happened if I changed the prompt to this, or what would have happened if I changed the tool description to this? Would that have given me a better result? And being able to see the results of that and kind of do that forensic analysis, I think is one of those parts of our platform that, it's open source. So I don't know who uses that and who doesn't use that, because we have no idea sometimes. So I think it's underused. I'm laughing because of the message as well too. I have to say, unfortunately, we are not built on Elixir. That is actually a different Phoenix tool that exists out in the wild. So there's a comment about whether we were built on top of Elixir and written in Elixir. Unfortunately, we are not written in Elixir. That is a sort of different tool called Phoenix. It's the downside of picking a existing word as our name. I don't know if you guys have ever run into that with Union, but something we see sometimes.
Yep, I've run that in many other companies I've been at too. It's a name and it's a cool word, and other people also have that. But yeah, I'm kind of sad because that person seems so excited.
I know, I'm bummed now. I'm like,
Elixir.
should we go back and look and see if there's a way we could incorporate some Elixir code?
Can you rewrite it all in Elixir?
Yeah, totally. I mean, we'll build an agent for that. We'll build a tool to do it for us. Yeah.
But yeah. Like I said, it's kind of sad. That person seems super excited.
Yeah.
Hate to disappoint.
Hey, we take contributions, so I'll just say it's an open source repo.
That's true. Open source.
Yeah.
You could go make the Elixir version to the person in the comments. as we kind of wrap up here, and hopefully you're okay on time, because I think we're even close to what I booked you for. Are there any other trends? Well, probably in the AI observability space, I'm guessing the self-healing thing is one of the trends you'd be excited about. Are there any other ones, or maybe just in the AI space in general, that you think is really interesting right now?
Yeah, there's a couple that come to mind. I think some that are more immediate term, like I think, for example, multimodal is this broader trend that we see like a lot of more multimodal applications. And multimodal evaluation is something that I think you're going to see more of over the next year. I think from us, from others as well too. We support kind of evaluating images as well as text, and then we actually just launched audio evals as a new kind of area and a new feature that we're doing some around too. And I think you're going to continue to see us and others kind of doubling down on that, because I think this idea of your multimodal application versus your like sort of unimodal or single modal application, I don't really think all applications are going to be multimodal in some way. Like you'll have capabilities around that for a lot of different types of apps. So you need your evals to be supportive of that as well too. So I think that's definitely one trend that you'll continue to see in the future here. And then I guess on the eval side, the other one that I would mention is something that I love right now that's happening is that people are starting to kind of take the existing benchmarks and evaluations that we use and realize that they're not actually indicative of real world performance sometimes. So if you heard us kind of like throughout this webinar, we kind of talked about building up evals and building up these systems almost by like taking these individual pieces and saying, if you, sorry, it's like a fire alarm or something. I think we're okay. You take these individual pieces and you say, okay, if this API call is correct, if this application code is correct, if this LLM call is correct, then we'll be fine and like the application will work correctly. And that doesn't scale to infinite complexity, right? Like your application will get more complicated. It'll be harder and harder to do that. And so having different evaluations that approach things from a different angle by kind of aligning it to a real world task, I think is sort of the future here as well. So you look at like we were chatting before about like 4.5 and some of these new models that are coming out. Every time there's a new model, they benchmark all these existing benchmarks. And like now everybody like blows MMLU out of the water. Like all these existing benchmarks are like we're hitting the top of those. People are coming up with harder benchmarks. But like something I love is if you look at the Anthropic one, you saw that they were benchmarking their applications on how far into Pokemon they could get. I don't know if anybody saw this, but like they would benchmark, okay, this new model 3.7 got to the third gym leader in Pokemon and it took this many moves to do it. And it was able to like figure out how to do that. And not that that's like a totally real world task, but I think people are coming at evaluation differently and saying, let's just give it the real world task and we'll see how it'll perform on that more holistically, as opposed to more of this piecemeal or more of, can it solve these coding problems? Can it generate text that fits this? So I think that's the other broader trend that I think I'm really excited to see is more real world, less contrived evaluations and tests for sure.
Yeah, I think that'll be a way better indicator over time for what models to use for different tasks, right? Like you said,
Totally.
Every time new thing comes out, blows the benchmarks out of the water. When I try to use it for something, not much better.
Exactly. We're building to benchmarks at this point, and I think that benchmarks need to shift.
Yeah. All right. So I have one last question. As long as the building isn't on fire and you can still.
No, we're good. I think we're fine.
What's like one piece of advice that you would give to teams that are just starting out with LLM observability, or maybe they're building an LLM application for the first time? Like, what are the biggest mistakes to avoid, and what's one thing you would do to help mitigate those?
I mean, I've said it a couple of times, but it is like start by looking at your data. Just start with that, get a sense of how things are performing. Just take the time to look into it and see. And then from there, you can build up the whole evaluation structure around it. And I mean, we see some teams now that are building to evaluation. They're doing like evaluation or test-driven development almost for their applications. And I do think that works pretty well with a lot of LLM applications. But I think you always want to start with that visibility, start simple and then build more complex from there. Start with the biggest models and then go down from there and see if you can retain the performance. So kind of take the easiest path, look at your data, and then build your system around that and kind of build from there. So the important thing is you do have to hit then build your system around that and actually do that stuff. You can't just kind of go straight through from the MVP all the way and launch with GPT 4.0 and no error checking. I think that is the step that has to happen. But yeah, I think look at your data and then be patient to build into that system as you go.
Yeah, and just to echo on that, totally agree. Look at your data and have something looking at your end data, like the results coming out of your LLM, which is what I think you're saying too.
Yeah.
Even if you don't know what metrics, I guess, to use yet, you're going to gain a lot of insight. And if you have a whole bunch of metrics that you're getting getting output from that, again, you'll gain insight of like, oh, like if you're looking at sentiment score or something, right? And just why is my LM so mean? Like how I'm going to go adjust my prompt or something like that. Like you might learn a lot that you didn't think was going to be happening. And then, yeah, like you said, then you kind of build that flywheel, kind of like a fine tuning flywheel, except for prompts and everything else in the pipeline, which is a great piece of advice, I think.
Definitely.
Cool. Well, that's I think we're at time here, basically exactly on the mark. Thank you so much, John, for being here, and thank you everyone who tuned in. I saw quite a few people and quite a few good questions. That was awesome. Thank you so much. I don't know if there was any other last questions or anything else you wanted to shout out, John. I will just say go check out their course on deeplearning.ai, which I think actually goes into a lot of the stuff that we just talked about here, and how to implement it around observing agents, which is really exciting.
Yeah, totally. Can I do 30 seconds and just hit the questions we didn't get?
Absolutely.
Yeah. So first one was, what are we doing on top of OpenTelemetry? We are built on top of OpenTelemetry, and then we can convert. We have an extra layer where we convert some OpenTelemetry traces into a format that can be accepted by Phoenix. So it's Open Inference is the name of the repo. It's its own open source tool there. So that was one piece that I wanted to make sure we touched on. And then Shriyang, to your question on whether we can parse and log think tags from, we can parse and log think tags as long as they're output by the model. So you need to have them in your Anthropic Claude 3.7, for example. We can parse those as well. So you can log those. And how can we identify frustrated users? We use AI. That's the answer for that one. So we have our own agent that can do some sentiment analysis over traces. So always try to make sure I get everybody's questions. Thank you, Sage, for letting me go back over that right at the end here.
No, thank you so much for doing that. I think it's one of the coolest things about doing something live is being able to get questions and interact with people. So again, thank you everyone for the questions and tuning in. And a huge thank you to John. Go check out everything they're building at Arize and Phoenix. Give their GitHub some extra stars if you thought this was cool.
Please, yeah.
And check out all the courses. They do a lot of great material around observability. So thank you everyone for coming out. I'm going to end the live stream. Thank you, John.
Thank you, Sage. Thanks, everybody.